All right, my second video here is on compounding objects and rotating motion. So we're going to be looking at two methods at which you could rotate an object. We're going to either rotate it using the rotate function, that's method one, and method two, which is over here, we're going to rotate it by using an axis, rotating the axes of the object that you're creating. So let's take a look at that right now. And then the final thing I would like to do is basically build a wheel and make it rotate. All right, so let's start off here with essentially how do we make this bar move right in here. So you were asked to essentially, below it is actually a code that doesn't work. So if I click on start, the object is not rotating at all. We just see a bar right in here. So if you haven't watched the earlier video, I would probably watch that first because I do go over basically how you update the angle from the angular velocity, and then you update the angular velocity using the angular acceleration. So basically how we're doing the Euler-Kromer method. But so I would recommend that you look at that. But let's just continue on here and see if you could I'll walk you through this now so that you at least have the solution for this now. So in the first part, I've just defined the objects. There's a scene and then just simply a bar. And you can see the size is just 2, and it's like, it's got a width and a depth of 0.1. And it's located at the origin. And you can see that the axis is basically pointing to the right. That's 1 for x, so it's pointing to the right. And then there's some color defined on it. And here the angle starts at 0, and the angular velocity is 0, and we're given a little bit of acceleration of 1. Alpha is the angular acceleration. And then we're going to run it for 5 seconds, and our increment of time is 0.01 seconds. So moving into here, our loop is mostly written up, but the lines that you have to change is line 22, line 23, line 24, and line 25. So this is what's key to remember. So how do we update the change in angular velocity? So just so you're aware, what we're doing here, I'm going to put a comment here, is we are calculating the change in angular velocity. That's what we're doing in this line. Okay, so how do we do that? Now, if you recall back to what I did earlier, if we want to update the angular velocity, we use delta omega is equal to alpha times delta t. And we're writing that in code. So in code, I'm going to put this in red, we're going to call that d omega equals alpha multiplied by dt. So we're writing that in code. So back over here, all right, so in that line, what you need to do is write in alpha. Oops, I'm not writing it in the right spot there. There it is. Okay. Alpha multiplied by dt. Next part. We now then need to update the angular velocity. So if you recall from my earlier video, how do we update the angular velocity? Well, it's the old angular velocity plus alpha times dt. And this is really just the change. That's what we call d omega. So omega will be equal to omega old plus d omega. Or if you want to write that more precisely, you could write as plus equals. So over here, into our code again, all right, you're going to change this line. So it's going to be, you could say omega plus d omega. Or you could do alpha times dt, but it's already calculated in the previous line, so let's just put it as d omega. So omega, there should be an omega in there. Alternatively, if you would like, you could write shorter, you could write plus equals. And that's a faster way of doing that. Okay, then d theta. How do we calculate d theta? D theta is really, well, the area under the angular velocity. So that little chunk, which is really omega, multiplied by the width of that, which is delta t. So our, where's our delta theta, I guess? Where's our delta theta? That's this line. Our delta theta is going to be omega multiplied by dt. Okay, so in code, in code, that would be, let's write that in here, it would be omega times dt. And then what's our new angle? Well, it's our old angle, theta, plus d theta. Okay, so this is calculating the change in angle. And this is essentially this line over here is updating the angle. and over here, or updating, sorry, not the angular velocity. All right, and then this last line here is updating the angle. Okay, so those are the key things that you should know, these lines. Now you could probably, I would say that you could combine them into one line, which you saw in the earlier video. You could combine line 22 and 23 in one line, and also the lines 24 and 25 in another line. Okay, the next part is how do you make the object rotate, all right? So there's a couple ways of making it rotate, all right? And you'll see this way is we're using something called axes. So the bar has an axis that points directly to the right. So if we think of this, I'm trying to think of a way to explain this. Maybe I go File and New here. Let's just make a new document so I can just write in it. If you think of it just basically a unit circle, all right? Let's say if I just draw a unit circle like this, or just an X and Y axis, and then I would just to make essentially a circle, but I need to actually center that circle. There we go. And then if I pick a point on that circle, like this point P, it has an X and a Y coordinate. And then if you think of it, really, you could think of that there is a particular radius and angle theta. So if you were to drop a vertical line here, whoops, not that way, drop a vertical line that way and a horizontal line across here, you'll see that it has an X coordinate and a Y coordinate. If you look at this little right angle triangle, hopefully you could see that on this triangle, right in here, this is really R multiplied by cos theta. And then this side is R multiplied by sine theta. So I can basically make this point P move in a circle by simply just making change its X coordinate, which is R cos theta, change its Y coordinate, which is R sine theta, and then just make the Z just be 0 because we're not rotating in that dimension. Okay, so back to the code. What do we need to change in here is you just need to change 2 is probably the radius of it, and you could just change 0 to the word theta. And then you can change 0 over here for sine and make it theta. So now, if everything works correctly, and I can run it, hopefully I will see a bar rotating once I click on the screen. There we go. And there's the bar rotating. And actually, if you notice, it is actually speeding up because there's an angular acceleration. Like if I didn't want it to continue getting faster and faster, I could change alpha to be 0, maybe give it an initial angular velocity of say 1. And then if I run it here, now I'll rerun it again, you can see that now the bar is just moving at a constant angular velocity. You know, you could kind of muck around with this. You could say, okay, I'm going to have an angular velocity of, let's say 2 here, and then make it an angular acceleration of, say, -1. What do you think would happen here? Right? Now it's rotating, you know, in the counterclockwise way, and then it starts to turn around and go the other way and start speeding up. That's because it has an angular acceleration that is going in the clockwise direction, but it started initially going in the counterclockwise direction. Okay, so hopefully you get an idea of how to rotate the object. So the key thing here, I guess, is this new thing in here. We can make the bar rotate by using the axis function. So a key thing that you need to probably remember here is if I want to rotate an object, I can use, like, let's say this is the command that you need to remember. So whatever your object is called, I'm just calling it object. And then I use dot axes, because that object has an axis, and then equals vec, because it's a vector. And then what you do is you're going to put in r multiplied. And you probably don't even need r. I'll explain that later. And then cosine of theta, comma, r multiplied by sine theta, and then comma 0. That's all you need to do to rotate the object. And in fact, you can, for simplicity, get rid of r because you could just assume it's a value of 1. It's really just what this ratio is of cos theta and sine theta is. So as long as you keep r the same, then you're fine. Okay, so one way to rotate an object is using the axis function. And so I would make sure that you know that, all right, and how you can rotate an object using the axes. Okay, so back to our program over here. Hopefully you can muck around with that. Make sure that you understand how we got lines 22 to 25, and importantly also how you can rotate an object bar dot axes. So have we answered these questions? We've made it, we've calculated omega in the loop, we've calculated the total angular displacement, and then we've rotated the bar to that new location, and we've simulated in rotational motion. Okay, now there is a second way of rotating an object, and that's using the rotate function. But before I do that, I think maybe it might be a good time to move on and make a second video and talk about compounding objects. All right, where's my pause button?